a point where whole weight of an object appears to be acting. Now, uniform square signboard of 0.68 meter is fixed at its corner point A and B to evolve. The sign is also supported by CD as shown. The sign has a weight W and center of gravity at point E. The sign is held in a vertical plane. The side BC horizontal. The wire is at an angle of 35 degrees. See the tension in this wire is 54 newtons. The force exerted on the sign at B is only in vertical direction. This is very important. Calculate the vertical component of the tension in the wire. Now, look, if tension is acting this way, this is tension, 54 newtons. This angle is 35 degrees. So there will be one horizontal component of this tension, which will be like this, and one vertical component, which will be like this. Okay. Now, how much will this be? In exam, because we are always against clock, so we cannot do the sine theta equals to perpendicular hypotenuse and find out the relationship all over again. So remember, the side which is alongside with the angle is always the cos component. So this will be 54 cos 35, and the side which is opposite to the angle is always the sine component. So 54 sine 35. So this will be 54 times sine 35. Can somebody do this calculation? What is 54 times sine 35?
Sir, it's 30.97.
30 point.
97.
Is this what you're getting?
Yes, sir.
31 newtons. Good. Now, explain why the force on the sign at B does not have any moment about A. Remember, the force on B is acting vertical. So when B is vertical, its line of action will be passing through A. So practically speaking, if line of action is passing through a point, its distance from the point is actually 0. So that means the line of action of B has no distance from A, so it is not producing any turning effect about A. Line of action of vertical force at B passes through A, hence no distance, so no movement. Do you understand?
Yes, sir.
If two forces are in the same line of action, they do not produce any turning effect with one another. And if line of action of a force passes through a point, its distance from the point will be zero. That means that force cannot produce any turning effect about that point. Now, by taking moment about A, show that the weight is 150 newtons. So A is a point over here. What forces are producing clockwise turning effect about A, and what forces are producing anti-clockwise turning effect about A? Listen, if this is the square, this is A, so weight, what do you think? Is weight producing clockwise turning effect about A or anti-clockwise turning effect about A? Let's say A is a fixed point. So this weight, is it producing clockwise turning effect or anti-clockwise turning effect about pivot? So Ban,
The clockwise.
good. And there was a tension acting like this. So tension had a component like this, 54 sine 35. So what do you think? What kind of turning effect is being produced by this force about pivot? Clockwise or anti-clockwise? Fifty-four sine 35. Is it producing clockwise or anti-clockwise? Subhan? Hello?
I think clockwise.
Listen, just think that pivot is a fixed point and this is a cardboard. Only 54 sine 35 is acting. Do you think that will make the cardboard move like this or like this? X or Y?
Anti-clockwise.
This force is trying to produce an anti-clockwise turning effect. Pivot is a fixed point, and you have to only imagine the force that we are talking about, 54 sine 35. And the way that is acting over here, it is supposed to produce an anti-clockwise turning effect. Now, there was another component. Don't forget about that one. 54 cos 35. What kind of turning effect is produced by this force about the pivot, Mariam?
Not sure, sir.
You have to be. It is not a difficult question. Just imagine that this 54 cos 35 is acting about in the direction shown in the diagram. Pivot is the fixed point. And just imagine it is a cardboard. You are holding it from A. Just hold a piece of paper in your hand from from its corner, bottom left corner. That will be A. And just apply a 54 cos 35 direction force, like a force in that direction. Will that be moving the cardboard clockwise or anti-clockwise? First of all, do you understand what clockwise and anti-clockwise mean?
Oh,
When we look at a clock,
sir, I know.
this is 12, 1, 2, 3. If something is moving this way, that is clockwise. And if something is moving opposite, that is anti-clockwise, this is clockwise. So let me know that there is only this force. Okay. Pivot is the fixed point, the triangle point is the fixed point, and only 54 cos 35 is acting. Do you think this cardboard will move clockwise or anti-clockwise just because of 54 cos 35?
Anti-clockwise.
So that means that it is producing an anti-clockwise turning effect. Okay, at one time you only consider one force. So there are two anti-clockwise turning effects and one clockwise turning effect. And remember, if this whole distance is 0.68, then weight, this one will be midway 0.34. So here we go. 0.34 W equals to 54 sine 35 multiplied by 0.68 plus 54 cos 35 multiplied by 0.68. Can you solve it for the value of W? So we find out we consider mass to be m, we find out gain of kinetic energy, we find loss of gravitational potential energy, we find their ratios, and the answer is 1.1. Now, okay, here we go. Second question. State Newton's second law of motion. Net force is directly proportional to rate of change of momentum. Okay. Now, a car of mass 850 kilogram tows a trailer in a straight line along a horizontal road as shown in figure 2.1. The car and the trailer are connected by a horizontal tow bar. The variation of the velocity is given so and so and so. Calculate the distance traveled by the car from 0 to 10 seconds. So 0 is 0. And at 10 seconds, this is the case. So how do we calculate distance from speed time graph? By finding its gradient or finding its area? Anyone can answer the question. How do we calculate distance from speed time graph?
The area under the
The
graph.
rate under the graph.
By area under the graph. So the lower rectangle is 9 multiplied by 10 equals to 90. Upper triangle is 1 over 2 into 10 into 1, 2, 3, 4, 5. 1, 2, 3, 4 into 4, 2, 2, 20 and 90. So total distance traveled will be 110 meters. The time t equals to 10 and resistive force acting on the car due to resistive and friction is 510 Newton. Tension in the tow bar is 414 Newton meter. Use figure to calculate the acceleration. To calculate acceleration, we need to find what? For acceleration, we need to find gradient. Okay. So here we already have this triangle. The rise of the triangle is 4 and run is 2. So acceleration is rise over run. So it will be acceleration equals to rise over run. Rise is 4, run is 10, 0.40 meter per second square. So this is acceleration. Use your answer to calculate the resultant force acting on the car. We know resultant force equals to mass times acceleration. Mass was 850 and acceleration is 0.40. So this will be 340 meter. Okay. $340 newtons. 1850 and 1850 is 1730, 400, 340 T. This shows the horizontal force of 1300 Newton exerted. Total force equals to net force plus resistive force. So total force will be net